So let's start with this one. So who's influencing it? The amount of shielding of the inner electrons, that is going to shielding effect, that is a factor. Then you've got the other factors are, you've got the charge on the nucleus. That's the number of protons. That is also going to affect the ionization energies, and the distance between the outer electrons and the nucleus, that is also a factor. So these are the three main factors. The fourth one is the net positive charge, and the fifth one is about orbitals, which happens when the dips happen. The next one is it also includes melting point, so we haven't done that, so we can skip that for now. Which property of an atom does not affect its first ionization energy? The atomic radius does affect the ionization energy. The number of electron shells that's shielding determines the shielding effect. That also affects the number of neutrons. Neutrons are neutral, so they don't attract or repel electrons, so they do nothing to I mean, the neutrons are in the nucleus. They don't attract electrons, so they don't really affect how difficult it is to remove electrons. The ionization energy will not be affected by neutrons. So that's your answer. Option number C. The 35th question is, why is the first ionization energy of aluminium less than that of magnesium? So this is across the period, comparing the first ionization energy. So why is aluminium less than that of magnesium? And the answer to that is that there's going to be a dip at, one second. So the answer to that is that there's going to be a dip at aluminium. And why is there going to be a dip? Because when you move from magnesium to aluminium, your orbitals change, your subshells changes. Instead of removing electrons from the 2s, you're now removing electron from the 2p, which is slightly more shielded, and it's a slightly higher energy orbital. So electron is removed from a higher energy p subshell, which is further away. So that's why you get a dip at group 3 when you move from magnesium to aluminium. So that's the reason for that. So the outer electron in the aluminium atom is more shielded from the nuclear charge. That is true. And that is true because the 2p is much further away. The two subshells, the 2s, is slightly closer to the nucleus. There's only one subshell that's coming in the way. The outer electron of aluminum atom is a higher energy orbital. That is also true. And it's also further away from the nucleus as well. So those are the three options. Why is there a dip at group 3? Again, it's successive ionization energies across the period. So the question is, remember this is group 1, 2, 3, there's a dip, 4, 5. There's a dip at 6, then 7 and 8. So which statement about this graph are correct? Elements B, J and R in group 18 of the periodic table. So J is over here, this is B, this is J, and this one is R. So they are the last element in the period. So they are in their noble gases. They're in group 18. That is correct. So atoms D and L contain 2 electrons in the outer shell. That means they're in group 2. So D is over here. That is group 2. And L is over here. That is also group 2. So group 1 has the lowest 2. There's a dip at 3. So that is also true. Atoms of G and O contain half-filled p orbitals. So G is over here, which this is group 1, then you have 2, 3, 4 and 5. So group 5, the electronic configuration is S2 and P3. Sorry, S2 and P3. Group 1 always has an S1 electronic configuration. This is S2, this is S2P1, S2P2, this is S2. This one is S2P3. So the P is half-filled. It's supposed to have 6 electrons, but over here it has 3 electrons. So it is a half-filled P subshell. So that is also correct. Okay, is this clear?
Yes, sir.
Okay, Mariam, is this clear? Lisha, Ania, is this clear?
Yes, sir.
Yes, sir.
Acha, these were we can ignore this. That requires some other knowledge as well. For the element sulfur, which pair of ionization energy has the largest difference between them? Now, this is successive ionization. You've got a sulfur atom and trying to sulfur has a total of 16 electrons. So that's 2 electrons in the first shell, 8 in the second, and it's got 6 electrons in the last shell. So which pair of ionization energy has the largest difference? Where do you get a jump? I mean, removing the first electron, easy. Second is easy. Third is easy. Fourth is easy. Fifth is easy. Sixth is easy. So the outer shell, not that difficult. Easy to remove electrons. As soon as you try to remove the seventh electron, that becomes difficult because now you're much closer to the nucleus. There's more attraction. So the jump happens between the sixth and the seventh ionization energy. The seventh one is the one that's harder to remove. The first six, easy to remove. The seventh one, all of a sudden, it becomes more difficult to remove. So the jump or the largest difference would be between the sixth and the seventh one. Is this clear?
Yes, sir.
So then again, the successive ionization energy. So you're removing electrons from the same atom. So which group is this in? First electron, easy. Second is easy. Third is there's a gradual increase. Fourth, fifth, sixth. And then all of a sudden, removing the seventh electron kind of becomes, it requires double the ionization, double the amount of effort. So that becomes very difficult. So that means the first 6 electrons were in the outer shell. So it's in group 6. So pick an element that's in group 6. I think it's DE. I mean, I have a periodic table over here. Someone in group 6. So TE is in group 6. So the answer is whatever the name of this element is. We did these questions earlier, so this one. The elements radon, francium, and radium have consecutive proton numbers in the periodic table. So what is the order of their first ionization energy? Which one is more endothermic? Which one is less endothermic? Which one is higher? Which one is lower? So radon, francium, and radium, they are consecutive. So look at the periodic table. Radon is over here, right at the bottom. So it's radon, then it's francium, then radium. So consecutive proton numbers. So you're going across the period, and then all of a sudden at radon, the period changes. You go to the next period. So what would there be? What would the ionization energies look like? Remember, this is group 8. Then the period switches. You move to group 1 again and group 2 again. So if I look at the consecutive. So if I look at the consecutive proton numbers, I'm basically standing at a noble gas, that's radon. So radon must be somewhere over here, right at the top. That's radon. I don't know. I think it's RA. Francium would be. Then you move to the next period. So francium would be over here, and let me just check what were the symbols of the elements. Radon is Rn. Sorry, francium and then radium. So noble gas group 8 or group 18. Then you have francium, that's group 1, group 2. So he's comparing the first ionization energy. Radium would be at the, radon, Rn would be at the top. And then the period switches and you move to the next period and the same trend repeats. It's francium, then it's going to be, what was the other one? Ra. Is this clear?
Yes, sir.
Yes, sir.
So which one is the least endothermic? That's the lowest one is francium and the highest one is radon. So least is francium, highest one is radon. So we're going to answer least is francium, and so it's going to be A. It's going to be A. So you were crossing the periodic table, dip at group 3, then 4, 5, then 6, there's a dip, then 7, then 8, that's radon. And then you move to the next period, so there's going to be a dip. Next period is always lower. It's the same trend, but lower. Because down the group, the atom size becomes bigger, so the ionization energies, all of them decrease. So it's Rn, francium, and radium. Right? Is this clear? Mariam, is this clear? Hania, is this clear?
Yes, sir.
Okay. Now, consecutive elements X, Y, and Z in the third period of the periodic table, element Y has the highest. So again, what you have is consecutive elements, right? So, and he's comparing the first ionization energy. So it could be consecutive elements would mean it could either be 1, 2, and 3. It could be this one, and this one, or this one, this one. So it's consecutive, right? Or it could be you'll be at the end consecutive protons. This one, and this one. So they're all consecutive, right? So the three elements that are consecutive, and he's saying that the Y has the highest first ionization energy. So Y has the highest, the middle one has the highest first ionization energy. So it could be that this is X, this is Y, and this is Z. So if it's this, like X is group 1, Y is group 2, and then there's a dip at group 3. So Y would have the highest first ionization energy. He was saying that Y has he did say that element Y has the highest first ionization energy. So it could be, it could be these three consecutive elements, group 1, 2, and 3. Or it could be this one, like if you have, so it could be this one, if you have X over here, Y over here, and Z over here. So again, it will be consecutive. X would have a lower ionization energy, then group 5, that's Y, that would have a higher ionization energy, and group 6, there's going to be a dip. So again, Y would have a higher first ionization energy. Or it could be, this could be X, this one at the top could be Y, and Z could be, now the next period is starting, right? So even in that case, so you've got three options. Even in that case, Y would have the highest first ionization energy. So the pair would be this one, either group 1, 2, 3, or it could be 4, 5, 6, or it could be 7, 8, and the next period. So he didn't say that they were in the same. He actually said that they were in the third period. So they're in the same period. So that means X, Y, and Z are out of the contention because Z comes in the next period. So we can get. These three options are gone. So it's just you have to choose or decide between this X, Y, Z or this X, Y, and Z. Is this point clear so far? Nabila, is this clear?
Yes, sir.
Mahad, is this clear? So it's either one of the two options. We talk about this one. So either group 1, 2, 3, or so it's either. Let me write this. It's either the consecutive elements belong to group 1, 2, and 3, or they belong to group 4, 5, and 6. So if it's so aluminium is out of the contention, like the first element is either going to belong to group 4 or it's going to belong to group 1. So aluminium, silicon, phosphorus, that's not going to happen. That's group 3, group 4, and group 5. That's not a combination. Magnesium is also out of contention. It's magnesium is group 2, group 3, group 4. So that's also not an option. You've got silicon, phosphorus, and sulfur. That's group 4, 5, and 6. So phosphorus is the one in group 5 is going to have the higher ionization energy. So he did say that Y is going to have the higher ionization energy. So this could be true. Or it could be sodium, magnesium, and aluminium. That's group 1, 2, and 3. So that is also. So it's either C and D, right? Is this clear up till this point? Hania, is this clear? Mayim? Zahib, is this clear?
Yes, sir.
Yes, sir.
Now, the only thing is you have to decide out of the two. So the next point was that Y is also supposed to have the lowest melting point. Now, we haven't done melting points yet. So I'll just tell you that in inorganic, you have to remember the melting points. The melting points of these elements are, remember the middle one should have the lowest melting point. So for melting points, I mean, I'll just open some notes over here. Just 1 second, where's inorganic? This is O levels. I said, please do remind me organic notes. I have the organic notes. Okay, I'll send them. As these are inorganic notes. Now we're discussing melting points. We haven't studied melting points. I'll just I mean, these are things that you have to memorize. I'll send them later on. I'll go through them. So where did period 3 go? Just a second. That was the first one, I think. Yep, this one. Now, remember we had, I can't draw on this. We had these 3 options: Na, Mg, and Al, silicon, phosphorus, and sulfur. These 3 options. 2 options. Either it's the first 3 or it's these 3. Look at phosphorus over here. It has the lowest melting point. Like if you pick silicon, phosphorus, and sulfur, then the middle one is going to have the element Y, the middle one is going to have the lowest melting point. So that is the option. If you had picked Na, Mg, and Al, the middle one, the Y, is not going to have the lowest melting point out of the 3. So it is the one with phosphorus. So that's going to be our answer. It's the one with phosphorus. Phosphorus has the, out of the 3, phosphorus has the lowest melting point. That doesn't happen with sodium, magnesium, and aluminium. Is this clear?
Yes, sir.
Achha, so which equation represents the second ionization energy? So which one is it?
B.
Okay, it is B. You've already removed the first electron and you're trying to remove the second electron, so it's B. And they're all supposed to be gaseous. Next one is, which factor helps to explain why the first ionization energy of group 1 elements decreases from lithium to sodium to potassium to rubidium? So you're going down the group, right? In group 1. When you go down the group, these atomic radius increases. The atoms become bigger. So the outer electron is much further away. So it kind of becomes easier to actually get rid of that outer electron. The ionization energy drops. And there's one other factor. Can you tell me what the other factor is when you move down the group? Anyone, what's the other factor? Alicia, any idea?
More shielding. Shielding.
Okay, so you have more shells as well. So the nucleus is covered by more shells, so it can't really attract the outer electron that effectively because there are too many shells around it. So there are 2 factors. There's one factor that actually goes against this, and that is the number of protons. They keep on increasing down the group, so that's the one that's going against it. So these 2 factors outweigh the effect of higher number of protons. Anyways, so why does it decrease? It decreases because the outer electron is in an S subshell. That doesn't really matter. The repulsion, forget that. The shielding effect of the initial increases. So D is correct. So it could have been atomic radius. They didn't give you atomic radius in the option, so that's not an option for you. Again, what type of elements are labeled X and Y? That's group 1. Group 1, group 2, dip at group 3, 4, 5, 6, dip, 7, 8. So X and Y are group 1. They're group 1 metals. That's easy. We had done these previously. So these are similar questions. I'm going to open some theory questions. The theory questions are kind of typical. You must learn how to write answers when you're doing theory questions. Just a second. Atomic structure. I'm saying this is 2018. This one. So the theory questions are kind of simpler and very typical questions. Most of the time, they're very typical questions. This is, I think, chemical bonding with shapes of molecules, bond strength. No, that's atomic structure. Probably this one. So these are very typical questions. But remember, learn to write answers. TK, most of you are very bad at writing answers. It's be brief, be to the point. Don't be don't write things in your own words. Like if this is science, so you have to use scientific terms and terminologies. There's a way to write answers. So explain why the first ionization energy decreases down the group. It's a 3-mark question. So when you move down the group, write it point-wise. Down the group, atomic radius increases. Or you can just sum up both points. Atomic radius and shielding both increase. And number of inner shells increases. So it becomes easier to remove electrons in spite of the fact that protons are also increasing. So despite the fact nuclear charge increases. So you've got, that's it, down the group. Explain for each element there's a large increase between the second and the third ionization energy. So you can see there's a large increase. Why is there a large increase? And these are group 2 elements. What happens when you try to remove the third electron? Anyone? It's a 2-mark question.
From a lower energy level.
Okay, so the third electron is removed from a lower energy level or removed from an inner shell. So it is less shielded, closer to the nucleus. Hence, it becomes more difficult to remove. The next one is they've given you group 7 elements, fluorine, chlorine, bromine. So there's not going to be a jump because you're removing the first electron from the outer shell, the second, the third, fourth, fifth, even the 6th and 7th electrons are removed from the outer shell. When you try to remove the 8th electron, that's when the jump happens. So why the ionization energy decreases down the group? It's the same reason. It's down the group you get more shells, you get more shielding, more inner shells, and the atomic radius also increases. So ionization energy would decrease despite the fact that there are more protons. Explain why there's an increase in the successive ionization energy. So if you keep on removing electrons from fluorine, it first becomes +1, then it becomes +2, then it becomes +3. You're continuously removing electrons. So why is there a successive increase in ionization energies? Because the net charge on the ion continuously increases. So the answer to that is so the net charge on the ion constantly increases. Is this clear?
Yes, sir.
Yes, sir.
So there is more attraction for electrons. Explain what is meant by the term ionization energy. It's the energy that's required to remove 1 mole of electrons from 1 mole of gaseous atoms or slash ions. So if you're using the word atoms, then to form 1 mole of gases plus 1 ions. You've got this element and they're saying state the group of the periodic table. What group is this in, this element? He's given you the removing the first electron, second, third, successive ionization energies are given, already given. So what is the group?
5.
Okay, so there's a gradual increase and then there's this massive increase. So that means this electron, the sixth one, is removed from a shell that's closer to the nucleus. So it's in group 5. The first 5 electrons are on the outside. So explain your answer. 1 mark for group 5. The other mark is that there's a drastic increase in ionization energies when you try to remove the sixth electron, which means that it's removed from an inner shell. And he says that the element belongs to period 2, so that would be group 5, period 2, that's nitrogen. So the electronic configuration of 7 electrons is going to be 1s2, 2s2, and 2p3. Okay, we already know it's in group 5. So right at the top of group 5, that's going to be nitrogen. Same exact. Explain why the first ionization energy of AR is greater than that of Cl. So why does ionization energy increase across the period? You got more protons, right? That's it. I mean, you're going to state that AR has more protons, right? So across the period, the number of protons keep on increasing. Why is Al less than that of magnesium? Same answer. We've done that many times. In Al, you're removing an electron from a higher energy p orbital, which is more shielded. Explain why the first ionization energy of S is less than that of B. That's because of spin pair repulsion. There's a dip at S. Why? Because so why is there a dip at S? Because that's your answer. Electron in group 6 is removed from a paired p orbital. So the two electrons are repelling each other. So there's paired p subshell, and due to spin pair repulsion, the two electrons repelling each other, they're going to make it easy for you to remove electrons. They're pushing each other out. In group 5, each orbital had just one electron, so that wasn't that big of an issue in that case. So what about... So most of it is just straightforward. Whatever we've written in the... I'm just looking for some... So most of them are kind of exactly the same what we've studied on the board. Okay, so they're kind of typical questions. Same thing, it's just why is there a dip at group 3? Why is there a dip at group 6? Why is ionization energy decreasing down the group? So most of them are kind of very, very typical. So we're going to move on, and I'm going to start a new board. This one is going to be about chemical bonding. It's just one second, let me... So we're going to start... And after chemical bonding, we'll start with organic. It's 1 second. So, chemical bonding, and I'm going to start. And just 1 second, let me add some. So that's fine. As anyways, so chemical bonding. And the very first thing that we're going to cover in chemical bonding is we're going to start with sigma bonds, and we're going to talk about covalent bonds initially. So what happens and why do atoms they bond? So number one is a sigma bond. It's a very specific type of bond which is formed between atoms. It's like a sharing of electrons. Uh, the first type of sigma bond, the very first type of sigma bond, that's known as an S-N-S overlap. So sigma bond number one, so it's an S-N-S overlap. What does that mean? And what is a sigma bond? So what that means is, like if you have an H2 molecule, now in O levels you studied that H has one electron. I mean, it still has one electron. So you got one H atom, and you've got another H atom. So both of them they have one electron each. So there's one electron. This H also has one electron. Now both the hydrogen atoms. And remember one thing, non-metals always try to gain electrons. Non-metals have this tendency to gain electrons. They always form negative ions. So what happens is that this H atom needs two electrons in its first shell. It's short of one electron. Its nucleus would be looking for electrons. If it sees an electron, it's going to try and pull that electron and try and get that electron, try to bond with it. This other H over here also has a nucleus. The nucleus is positively charged. When it sees the electron of the other atom, it tries to bring that electron close to it and tries to bond with it. So what's basically happening is that both atoms are fighting over electrons. They're trying to gain electrons. This atom over here is trying to gain electrons from the other atom. This atom over here is trying to gain electrons from this atom. The end result is that no one is able to gain those electrons because it's like two people fighting over the same thing. So the end result is that both atoms they get pulled closer together. It's like two people pulling on the same thing. So the electrons are stuck in the middle, there's a hydrogen atom on this side that's trying to pull those electrons. There's a hydrogen atom on this side that is also trying to pull those electrons. So that's known as a simple covalent bonds. That's the sharing of electrons. The electrons don't go anywhere. It's like a tug of war. The electrons are stuck in the middle. Both H atoms trying to pull those electrons in different directions. So this one is trying to pull electrons towards itself. This nucleus is trying to pull electrons towards itself. So the electrons and the forces of attraction, they kind of get cancelled out. The electrons are right in the middle. They don't go anywhere. This one is not able to gain them. This one is also not able to gain them. So they mutually share them. Is this clear?
Yes, sir.
So what's a sigma bond? A sigma bond is, and we're going to talk about sigma bonds tomorrow now because we're out of time. So remember, we haven't started yet. We just showed a covalent bond. And tomorrow we're going to discuss what is a sigma bond and what is an SNS overlap. Okay, so we'll do that tomorrow then. So then let's continue tomorrow then. Okay, everyone.
Thank you, sir. Allah Hafiz.
Take care, Allah Hafiz.
Love. Thank you.